Hi, on behalf of 24 Hour Answers team, I would like to welcome you to today's lesson. Today's lesson is capacitors with working examples. Example number 1. Find the charge of the capacitor if the potential difference between the plates of the capacitor is 20 volts and the capacitance is 10 nanofarads. If the potential difference increased to 40 volts and we wanted a charge which is half of what it was, what capacitor should we use? In the first case, we have V equals to 20 volts and C equals to 10 nanofarads. To calculate the charge of the capacitor, we'll use the formula on the screen. Q equals to C times U or C times V. In the end, we get 200 times 10 to the minus 9th coulombs. In the second case, we have V equals to 40 volts and Q equals to 100 nanocoulombs. To calculate the capacitor needed, we'll use the formula. C equals to Q divided by U or Q divided by V. In the end, we get 2.5 times 10 to the minus 9th farads. Example number 2. If we wanted a capacitor of C equals 4 millifarads and had a material with a relative permittivity of epsilon r equals 10 and the distance between the plates was d equals 10 millimeters, what should the area of the plates be? If the distance between the plates changed to d equals to 15 millimeters, what would be the capacitance of our capacitor? In the first case, we have all the information you can see on your screen. To calculate the area of the plates, we'll have to use the formula for capacitance and move it around a bit. You can see that on your screen. C equals epsilon times S divided by D, or epsilon 0 times epsilon r times S and then divided by D. The final formula that we need is S equals to C times D divided by epsilon 0 times epsilon r. When we substitute the values in it, in the end we'll get 0.451 times 10 to the 6th square meters. When you take a look at the result, you figure out that those plates are huge. Sides of this capacitor would be around 671 meters in length. In the second case, we have all the information you can see on your screen. In order to find the new capacitance, we'll use the appropriate formula. C equals to epsilon times S divided by D, or epsilon 0 times epsilon r times S divided by D. When we substitute the values that we have in it, in the end we'll get 0.266 times 10 to the minus 2nd farads. The capacitance has decreased as expected. That should be it. Thank you for your time. Check out our YouTube channel for more lessons.